Hello everybody, hope you are all doing great. Welcome back to my YouTube channel, Data Science Galaxy. Hope you are all familiar with a popular technique called Logistic Regression. Logistic Regression is considered a white box model, meaning you are not just able to predict in a particular classification setting, you are also able to interpret with reasonable level of acceptance and explain the regression coefficients in a logistic regression. Logistic regression belongs to a class of models called generalized linear models and very popular particularly for binary or bipolar classification problems. Having said that, there are sometimes people face difficulty in interpreting the coefficients, particularly because it uses the idea of odds and probabilities, unlike regression coefficients that people interpret easily, relatively speaking, in a multiple linear regression setting. So in this video, I am going to demonstrate to you with an example and explain how we can go from log odds to odds and to probability with multiple examples. If you are excited, please stay tuned and watch this video till the end and you will not be disappointed and it will be completely worth your while. Without much ado, let us get into the demonstration itself, shall we? So friends, for simplicity of explanation, I'm going to create a simple mathematical representation of a logistic regression model where I'll have only one independent variable x. And what you get in a logistic regression is log odds. Log of odds, so I can represent it like this, is equal to, let us just say I'm going to create some coefficients here, 16.1259 plus, let us just say 0.5878 times x. This is your log odds representation of a logistic regression model with one variable x. So I think let me just zoom it a bit because you can see it clearly and it is recorded well for easy viewing. So I'm going to separate these coefficients into different columns so that I can show some computation using examples. So I'm going to say minus 16.1259 in this cell, and in the adjacent cell I'm going to say 0.5878, and in the last cell let us say I'm going to call it x and we are going to substitute a value for x. Let us just say for example I can take x to be, let us just say 28. So what I've done, I've taken from this right hand side of equal to, separated the values into three different columns. So what we can calculate is for a value of x being 28, we go ahead and create the log odds. So what will be log odds now? I'm going to say log odds is equal to, we can think of it as equal to, I will say this value of minus 16.1259 plus we have the value of 0.5878 multiplied by 28. So this is what you will get, 0.3353. Let us keep it at full 4 decimal places. It's all right. So here is an important question to think about. What I've got is the log odds and x is independent variable or an attribute. Here is the first question that I'm asking you. In a logistic regression setting, is this log odds, should it be related to the independent variable or an attribute in terms of linearity? Should this be log odds linearly related to the independent variable x in a logistic regression setting? What do you think? If in case, let us just say if in case the log odds, that is log of p by 1 minus p, is not linearly related to independent variable x, let us say in a logistic regression setting, what do you think would be the consequences? Please go ahead and draft your comments in the comment sections down below. So let's continue. We have calculated the log of odds. All I've done is taken the value of x is equal to 28 and substituted in the above mathematical representation. So from this log odds, you have to go to calculating the probability. So before that, I need to get rid of this log. How do I do? I want to get only the odds on the left hand side. For getting the odds on the left hand side, how will I do? I have to exponentiate the right hand side and the left hand side because logarithm and exponentiation are opposite of one another. So I'm going to exponentiate, so logarithm gets cancelled out. So I shall remain with only the odds on the left hand, and on the right hand side I'm going to say equal to sign for invoking the Excel function, and I'm going to make use of this value 0.3353 and then exponentiate them on the right hand side. So what you get would be a value 1.39835983 for the odds. From the odds I have to calculate the probability. From the odds I have to calculate the probability. What is the probability and relationship between probability and odds? Probability is equal to, I'll just write it here, is equal to odds upon 1 plus odds. So in the above step I've calculated the odds, so I can calculate the probability now. So I'll put it here. So probability, let us say I'm going to say probability, that is equal to, this is odds divided by 1 plus, again the same cell I select, voila, I get the probability to be 0.58. So we have started with x is equal to 28, converted that into odds using the idea of exponentiation, and therefore calculated the probability using the idea of odds. So when a value of x is equal to 28 is substituted, you are going to get a value for probability that is 0.58. Remember, always probability should be between 0 and 1, cannot be negative and cannot be greater than 1 while being positive. Notice something here, we have probability to be 0.58, let us just highlight this and keep it, and I want to draw our attention to the odds. For the probability of 0.58, odds is 1.3. You notice here odds is greater than 1. So therefore, while probability has to be in an interval of 0 to 1, odds can be greater than 1. Okay. If I change it to some other example, see what happens. I'll take, let us say, 25 for the x value, and see, log odds is negative, odds is 0.23, probability is 0.19. Just for thoroughness, I'm going to increase x value to, let us say, 33 and see what happens. Log odds is 26, probability is 0.96. If you go on varying the value of x, you'll get a sense of what the odds are for that value of x given this mathematical representation, and therefore you can calculate or compute the probabilities. Always remember, it cannot exceed 1. If it exceeds 1, you're doing something wrong, or if it is negative, you're doing something wrong. So here are 3 important questions that I want to ask. 3 or 4, okay? First one I already asked, I'll just bring it focus now for those questions. 1. Should this log odds be linearly related to the variable x? Let me repeat for completeness. Should the log odds be linearly related to the independent variable x in a logistic regression? Second, can the odds be negative? Think about it. That is the second question. Third question, you observe this probability, it will approach 1 or it will approach 0 depending on different values of x. Here are 2 questions related to probability. For exactly what value of the probability, you will get odds is equal to 1. See here, for the value of 33, we have the probability 0.96 and odds is 26.43. For what value of probability, odds would be 1. Okay, that's the third question. Fourth question, for what value of probability, odds is not defined? Hope you are clear on the question. Fourth question. For what value of probability, odds is undefined? I want you to think about these 4 questions and drop your inputs in the comment sections down below. I think it will be interesting for you to be able to apply yourselves and then come up with answers. Okay, don't hesitate to share your thoughts, share your inputs, share your answers, ask any questions related to what I covered. I think this will be very helpful for you to interpret regression coefficients being a white box model. Okay. By the way, I have created a full-length video on logistic regression itself on my YouTube channel, where I have discussed at length the end-to-end perspective of logistic regression and, more importantly, busted some myths that are floating around in the public domain. Don't forget to check that out. I'll leave a link in the description box down below. Having said that, if you are curious to know the answers for the questions that I asked in this video, make sure you're going to subscribe if not already. Hope you have liked what you saw. If so, give it a like, share, subscribe, and don't forget to enable the notification for not missing any upcoming videos. On this channel, I am going to constantly upload interesting videos that will help you to add to the cumulative knowledge, and therefore takeaway would be from the real learning practitioner's perspective. Please stay tuned for more, and I'll talk to you in my next video. This is Manjunath signing off. Bye-bye. Take care. Happy learning.